My name is Leah and this is Oskar, and we're from the Planeteer. Basically, we're here today to introduce to you our new low-cost water meter. It's for use in Cambodia. Okay, our company has been requested by EWB on behalf of RDI Cambodia to introduce a low-cost water meter for use in the Kandal province of Cambodia. In this region, the water supplies are limited and unsafe. Basically, they have to collect their water from groundwater or from wells, most of which are contaminated by arsenic. Other organisations are currently available to install gravity-fed tanks into the household. However, in order to do so, they require something to meter it so that it can be paid for. So currently, there's actually a meter available. It's $50 US, which for some of the Cambodians is far too expensive. Most of the people actually live off about $3 US a day. So we're basically, in Cambodia, our product promotion was mainly word of mouth. There's no electricity, TV, radio, that sort of thing. So we're going to look at sort of lots of product demonstrations, things like that. Our pricing. So because we're a not-for-profit organisation, we're actually selling to the Cambodian people at cost price. So basically the meter we sold on the condition the buyer adheres to a simple payment plan.
Every water meter is made up of two parts, the register and the flow meter. The flow meter physically measures the water flow through the meter and the register displays that measurement. There's two categories of meters, velocity meters and positive displacement meters. Velocity meters use that formula to calculate the flow rate, and positive displacement meters divide the water into discrete quantities and count them. Sort of like if you build up a lot of glasses of water and count how many you have. The single jet meter works by having a jet of water flow past a little impeller, which measures the speed of the water. This is the only velocity meter that we found applied to our project. The mutated disc meter, it's fairly simple in construction. It only has the one moving part, but as the disc rotates, it needs a spherical chamber, which is fairly complex to manufacture. The oscillating piston, the picture looks pretty complex, but it's pretty simple. It's made of cylinders. The piston, which is in blue, rotates around the central circle there, like a hula hoop, and that pushes the water in the orange area around from the inlet to the outlet, which measures the water. These are some other ones. There's two ways to display the usage. One's just a counter, and the other is using a dial. Most meters use a combination of the two, with the dial displaying the lowest unit. The register can either be mechanically connected with a shaft, which is good because it makes it very tamper-proof, but otherwise you can have it magnetically connected. This unfortunately lets magnets interfere with the metering, although the benefit of the magnetically connected one is it can be detached from the actual meter. We looked at several criteria to benchmark our water meters, the water meters we looked at. They are a combination of what was relevant to our project and what was available from the manufacturers. We decided the most important was the lower flow rates, as there's not going to be a high water usage in Cambodia. As you can see, the oscillating piston meters are the best in that category. So in conclusion, the most promising design so far is the oscillating piston meter, and if possible we'd like to have it magnetically connected to the register. Any questions?
Part of the cost is also the ongoing cost, so it's servicing and the calibration and all that sort of stuff. And one of the design criteria we're looking at is like a detachable, like using a magnetic couple. I'm sure you've seen, like, if you place like a magnet on a table and put another magnet underneath, it also moves with the one underneath. That's a similar thing we might be incorporating in design. Instead of like a mechanical shaft connecting